Problem, we're supposed to look at f of x is equal to x squared times the square root of 1 minus x cubed and determine where this has a horizontal tangent line. We first observed that the domain of this is going to be anywhere where 1 minus x cubed is greater than or equal to 0. Okay, so the square root function is only good where the thing under the square root is non-negative. And so this means that x cubed has to be less than or equal to 1. And so if I take the cube root of both sides, that means x must be less than 1. So this function is undefined if x is less than or equal to 1. This function is undefined if x is greater than 1. However, if x is less than or equal to 1, the function is perfectly well defined. Okay, so that's the first thing I observe. To determine where this has a horizontal tangent line, I take the derivative. And so I get that let me just recopy the function here. F of x is equal to x squared times the square root of 1 minus x cubed. That's my original function before I take that off screen. And so the derivative I get by using the product rule. So the derivative of the first times the second plus the first times the derivative of the second. Okay, now the first one's easy. Derivative of x squared is 2x times the square root of 1 minus x cubed. This requires using the chain rule. So here I have x squared times, all right, this is 1 minus x cubed to the 1/2. So I have 1/2 times 1 minus x cubed to the negative 1/2. This is 1/2 minus 1. So I subtract 1 off the exponent. And then I multiply by the derivative of the inside to get negative 3x squared. And so that is the derivative. All right, now to be able to complete this problem, I must simplify this because I will be setting the derivative equal to 0. And so it is certainly in my best interest to simplify this as best as I can. All right, so let me write this as 2x, 1 minus x cubed to the 1/2. And then I have plus, actually, let's make this minus 3x the fourth over 2 times 1 minus x cubed to the negative 1/2. Okay, so what should I do to factor this? Well, certainly I can factor out an x. I should factor out the 2 in the denominator. And I should also factor out the least exponent of 1 minus x cubed. So 1 minus x cubed, and what will be left is negative 1/2. All right, now what is left when I simplify? Let me do the second part first. So on the second part, I would have that I factored out an x, so that leaves an x cubed. I leave the 3 here, so the 3 and x cubed. If I multiply this together, I get 3. Then I have x cubed times x makes x to the fourth. I've got the over 2, and I've got this term right here, so that matches. On this term, I would have, I factored the x out, so there's no need to have that. I factor out a half, so that leaves 4 inside, because 4 divided by 2 is equal to 2. Also, what's left is 1 minus x cubed to the first power. Because if I multiply this times 1 minus x cubed to the minus 1/2, I would have 1 minus x cubed to the 1/2. Okay, so I have x over 2. And let me put this in the denominator, square root of 1 minus x cubed. And the thing in brackets is now 4 minus 4x cubed minus 3x cubed. And that becomes x times 4 minus 7x cubed over 2 times the square root of 1 minus x cubed. And so that is the derivative f prime of x after doing my simplification. Okay, now to find where the horizontal line, the tangent line is horizontal, I solve f prime of x is equal to 0. And so I have x times 4 minus 7x cubed over 2 times the square root of 1 minus x cubed is equal to 0. Okay, well, I can multiply up the denominator. Said another way, a fraction is equal to 0 exactly when the numerator is equal to 0. So x times 4 minus 7x to the third equals 0. And so this happens in two places where x is equal to 0 and where 4 minus 7x cubed is equal to 0. This one's easy. And so the second part is 4 is equal to 7x cubed. X cubed is therefore equal to 4 sevenths. And so x is therefore equal to the cube root of 4 sevenths. Okay, and so that is our answer. So values of x, where there's a horizontal tangent line, will be x is equal to 0, and also the cube root of 4 sevenths. And those are my two answers, the two values of x where that curve has a horizontal tangent line. As a way of checking this during the exam, one could go back to the original function, graph this, and then confirm that at these 2 points, and this one you'd have to compute on the calculator to make sure that it's decimally accurate. At those 2 points, the graph does indeed have a horizontal tangent line and appears to have a local min or a local max.